Welcome to this week's episode of Online Learning. We are continuing to expand our knowledge of science this week. Today's topic, all about the states of matter. The states of matter. So, join me this week. We're going to do a very quick, less than 2-minute review of what we've been talking about. So what have we been talking about? Well, we've been talking about matter, and matter is made up of atoms, which is everywhere. It's in me, it's in you, it's in my cute little dog Belle right there. Isn't she cute? It's everywhere. And what are atoms made up of? Well, just as a quick reminder, this is our atom, and we've got inside the nucleus, in the middle, in the center of the atom, we have our positive protons, we have our neutral neutrons, and then on the outside we have our electron orbits, which has our negative electrons. This is our atom. And remember, charges, things can have a charge. And just as a very quick reminder, things with like charges, they repel. So 2 positives and 2 negatives repel. Neutrals don't do anything. And opposites attract. Is a very quick reminder. Also, we talked about the properties of matter. So all matter has properties, whether that's chemical properties or physical properties. So chemical properties, these are properties that are measured by changing the substance chemical structure. This would be like combustion or reactivity. So if it's reacting with oxygen or water. Also flammability, like lighting a match. Or basically flammability means that, is it going to react to a flame? Is it going to burn? Physical properties. Now these are properties that can be measured or observed without changing it at all. You're not changing the substance. This is like color, density, volume, mass, boiling point, melting point, all the points. Those are our physical properties. Properties are, really, these are our properties, but matter can also go through some changes. We have chemical changes, we have physical changes. Now chemical changes, remember, that's a chemical reaction occurs. Then we know that's when it goes through a chemical change. This would be again like burning, like lighting a match, or something rotting, fireworks, and also cooking. And again, if we remember from last week when we cooked our egg, where it's cooking, we went from a raw egg to a cooked egg. That's a chemical change, because when we cook an egg, we are kind of like changing the chemical properties, the structures within that egg. Essentially, and I know I didn't talk about this last time, but we're breaking down the proteins. And that's also, we know that it's happening because this gas forms and we can smell it, which was that sulfide gas. Physical changes. So this is where matter changes form, and not so much chemical identity. So this would be like painting your nails, boiling the water, melting, chopping wood, shredding something. All of that are physical changes. So physical changes, we're kind of going to look deeper at that today. We're going to look at boiling some water. Woohoo! Super exciting. So as we talk about boiling water, we're going to do a quick demonstration. And you can do this at home too if you wish. So all you're going to need this week is a pot that has a lid. Add some water in it, like I've done here, if you can see it. And a glass dish that fits inside your large pot. And then also some salt. So our first step this week is going to be adding some salt to the water. This week's demo also involves the stove again. So if you're going to do this at home, make sure that you do have parent supervision and that you're careful. I don't want you to burn yourselves. So again, we take our pot full of water and we're going to just kind of pour in some salt there. Pour in a little bit of salt, make it nice and salty. Now, fun fact, or if we remember from last time, when I add salt to water, am I making a compound or am I making a mixture? So remember, when I add salt to water, which is it? Hopefully you were thinking about it and remembered that I'm making a mixture, because I'm not changing water. I'm not making a whole new compound. I'm not making a whole new thing. I'm just adding salt to water. So the properties aren't really changing. Technically, they change like a little bit because the properties combine. And so, fun fact, when you add salt to water, it's old wives' tale that, you're making it, you're going to be able to boil it faster. Kind of true, kind of not. So where it's kind of not is that you aren't lowering its boiling point, meaning that it doesn't take a lower temperature for it to boil. What actually happens is that if you have to add a lot of salt to it, so if you mix a solution where you have a bunch of water and 20% of that water is going to be salt, then you're gonna really see that it's gonna boil a lot faster. But it's not because you're lowering the boiling point. What's actually happening is when you add salt, remember salt is sodium and it's chlorine. And so sodium is technically a metal. And so salt itself has a very low heat capacity, meaning that it doesn't take a lot for it to heat up quickly. So it's gonna heat up really, really fast compared to water. So when you pour this salt in, it's gonna heat up really quickly, which is important because also when you add that salt in, it's blocking heat molecules from escaping. They can't get out. And so that means that its boiling temperature, its boiling point, increases. So the boiling point of water is actually 100 degrees Fahrenheit, but when you add salt in that, or a lot of salt, remember a lot of salt, that boiling point goes up. But it's able to boil faster because with all the salt in there, it's able to heat up a lot quicker and reach that high temperature faster. More you know. But anyways, when you cook, you don't add that much salt to it, so it doesn't make that much of a difference. It's more for taste. So anyways, this week, we're adding again that salt to our water, and we're gonna use our knowledge of kind of that physical property of water, of its boiling point, and also the physical change that occurs when we boil water. So let's go to our kitchen and we're gonna see what happens. And I'm gonna show you how to do this experiment, and then afterwards I'm gonna explain what we just did. See you there. All right, welcome to my humble kitchen. So I already have the pot on. I already had the water in it. You watch me put some salt in it. And we have put it on the stove, and now we are just gonna wait for it to boil. If you see, I put it on high, but I wanna be careful because I don't want it to boil to like be over boiling, essentially. So now we get to play the exciting waiting game and wait for this to boil, and I'll show you the next step. Go. Okay, so now that it's boiling a little bit, it's kind of getting a little bit of a boil. I'm turning it down because again, like I said, I don't want it to boil too much. Then I'm gonna take our glass dish and place it in there. I'm gonna use tongs because it's a little hot, and I'm just gonna let it float in there. You just have to be careful to not get any of the salt water in it. And then I just put our top on. Oh, I gotta put it on upside down. That's right. And it's hot. And now we just play the waiting game and wait to see what happens. All right, it's starting to boil. Well, I mean, it's already boiling, but as you can kind of see in the top, as you see the water collects on the surface of the lid of the pot, you can see it dripping towards the center. This is why we have the top of the pot, the lid really, inverted or upside down, because as it kind of goes down to the curve, it starts to drip into the glass dish. You can see the outline right there. We're gonna give it a little bit more time and we're gonna see what we collected. Okay, so I stopped it a little short because we're gonna see what little we collected because this isn't a perfect system. So let's see what little water that we collected. I'm not gonna use my tongs because they might slip. I'm going to use a little scooper, and let's get this out and see what little water we collected. There, and as you can see, we collected some water that was collected from the steam. And so we'll go over more of what this process is and how we just did it once I meet you back at the main staging area. See you there. Wow, wasn't that a really cool experiment of boiling water and watching it boil? Super awesome, right? But anyways, this is actually a really cool process and it's vital. We use it every day. This process where we turn that water into steam, because it's still technically water, it's just in gas form, and we left the salt behind and we got our pure water in our glass dish. This is called distillation. I'm sure you've heard that before. You've seen it at the store where you can buy distilled water. We just distilled our own water. You don't have to buy it. Basically what this is, you're purifying the liquid through a way of heating and cooling, just like we did. So basically as this goes, it removes impurities, like harmful microbes like bacteria, and most minerals. They get left behind. Not all minerals can be removed. It really depends on their own boiling point, but a lot of minerals are left behind, which is why that having distilled water in hospitals and dental facilities is important for them to have. They don't want to have those with the water when they're cleaning their materials. And just also FYI, when you filter water with say like a Brita filter or you have a filter on your faucet, it pretty much does the same thing. It just doesn't really remove as much minerals as say distillation does. So why did this happen? What do we do to create this process. What do we add? Think, what did we add? I put it on a stove and we added heat. Your answer should be heat. And what is heat? What is it? It's energy. It is energy. So what is energy? Do we remember? So energy is a description of phenomena. We use it in science to describe something that is happening in the world that we see all the time. It's everywhere and it's in everything. It's in me and it's in you. Energy refers to this concept that can basically be broken down to mean the potential for causing change. Thus, energy is behind any change that happens. The true definition of work, is the work that a certain force can do. Basically, that means that any force that's like a push or a pull, remember, that could be done by gravity from the earth, or it could be done as an actual push or an actual pull, or from like electromagnetic forces. Anytime that there's like that force that's making something move means that energy is involved. And there's different types of energy. They can be classified into all different types. Some of these are kinetic energy. That's a really important one that we'll be focusing on. And kinetic energy is the energy of movement. Potential energy. Remember, that's stored energy. That's the energy like if you're at Six Flags and you're at the top of Goliath, right before you come down, you have a lot of potential energy to fall screaming back down towards the earth. There's also thermal energy. Remember, that's heat. That's what we added to our pot of salt water. There's electrical energy. We use that to charge our phones and our iPads and our fancy technology. That's energy of particles moving through a wire. There's also chemical energy. That's the energy stored in the bonds of chemical compounds. So that's the energy stored in your food. When you eat it, digest it, you're breaking those apart to be able to eat it. And that energy gets there in your food, especially if you ate a plant, like say a cucumber. That comes from photosynthesis, from the sun. So before we talk about kind of like that energy, we first need to remember the states of matter. How many states of matter are there? I might surprise you. Think about it. There are 5 states of matter. Yes, there are 5 states of matter. 4 are occurring naturally. That 5th state of matter is something called the Bose-Einstein condensate, which is man-made. So we're not going to really talk about it that much. We'll focus on the 4 natural states of matter. First one, number 1, solids. These come in different sizes and shapes, and solids encompass like a huge diverse group of materials. Their properties can vary greatly. So like my iPad is a solid, can't really bend it. It's stiff, it feels interesting. This is a solid. It's a little bit smoother than my iPad, Mr. Einstein here. Also, this salt container is a solid, but it's also kind of squishy. I can bend it. This is also a solid, but if I drop this compared to the other ones, this might shatter. I am a solid, just like you are a solid. So if you like feel your arm, like you can feel your skin is kind of squishy, you feel your bone inside, and that's like a lot harder. So solids really come in different shapes and sizes and all have different kinds of properties. Again, that's because of how they're made up. Liquids. Now these are more free-flowing. So like the liquid in the dish that we have, that's a liquid. Very free-flowing, go with the flow. They have a volume. And fun fact about liquids, the most viscous liquid, remember viscous? That means the measure of how easily a liquid can flow. The most viscous liquid is pitch, and that is what's used for road surfaces. Gases, that is our 3rd state of matter. So gases, what's our example for gases? Look, right in front of your face, it's right there. Can you see it? Probably not, because it's air. Air is a gas. Gases are all around us, and the way that they behave is vital for life on Earth. Why? Because we need to breathe. Gases are vital for us to breathe. We can't drink oxygen. We breathe oxygen. We're not a fish. So we'll kind of get into kind of those gas properties a little bit later, but these are our 3 main states of matter: solids, liquids, and gases. We'll get to the 4th one, plasma, in a little bit. So we're going to kind of look at these states of matter as we explore our water molecule. So let's review what our water molecule looks like in a little animation. So I'll see you as an animated me.